will be recorded. Okay. So this is it, simpler systems. Many will be familiar with this. They have fewer parts, relatively low connectivity, fewer interdependencies, relatively static, so on and so forth. Complex systems, highly dynamic, many parts, interconnectivity, interdependence, and they're continuously kind of evolving. This is kind of what we're talking about when we talk about designing complex systems, smart cities, organization design, Internet of Things, platforms, supply chains, information systems, transport systems. These are all complex systems that we're trying to design. Indeed, all kinds of kind of service systems, really complex service systems we're talking about here. And these are the principles. Well, these are some of the aspects to characteristics of complex systems, right? They're open. They have these emergent kind of features to them, put all the parts together, they interact in kind of non-linear ways, and we get the emergence of something greater than the sum of the parts. They're adaptive and they kind of evolve over time. They're multi-dimensional. They're always consisting of many different parts, like a city. You know, it would have to consider many social and economic, environmental, technological factors. They're self-organizing. The parts interact. They can't be fully kind of controlled in a centralized fashion. They have this kind of decentralized peer-to-peer interactivity that leads to the emergence and self-organization, and they have this kind of network structure to them. So those are the aspects of complex systems, and then, yeah, we're trying to.
Can you give me co-host thing so I can let people in?
Sorry, John. Yep. Make co-host. There we go. You should have it now. So these are the principles, right, that we've been looking at. We started off talking about holism as really a very important one here. We've had many discussions about that, integration, patterns, multidimensional. These are the aspects to complex systems. And let's just see down here quickly what we've been covering so far in the past 4 months. We've been doing this one, these principles. First one here, as I said, was about holism. So we looked at different dimensions to that, multifunctionality, kind of pattern-based approach, integration, so on and so forth. After that, we looked at this aspect of kind of open systems and how we design for open systems. We can see here some of the things we covered. Designing for context, designing for self-organization, designing for emergence, so on and so forth. We then looked at a relational approach, designing for connections and protocols and synergies. This is what we looked at last week, and non-linearity and circular design also. So there we are. We're now up to speed, and this is where you guys should be and what we're working on today. As I said, it's going to be an interactive discussion. If you're new to this, how it works is hopefully you'll join me here on the Miro board. And I'm going to give a little intro first to what we're talking about, but then after that, I'm going to ask you to grab some stickies and answer some questions here. And then we'll go through that, having a discussion around what you posted. So today we're talking about networks and decentralized networks in particular. This is an aspect of complex systems. They don't have kind of full centralized control. They're often distributed out, and no one's really fully in control. You know, the internet is a very good example, or even the human brain actually is a good example of a complex system, and there's no kind of one part controlling all the others. It's many different networks kind of interacting, but the internet is a very good example, right? No one's really controlling the whole thing. And how do we work with systems like that? How do we design those kind of decentralized systems, these networks? Let me say a few words on that. As we go from a system with relatively low level of connectivity to one with a very high level of connectivity, the makeup and behavior of the system changes fundamentally. In relatively isolated systems, our focus is on the components and their properties. Due to the high cost of interaction, the system is typically bounded within a centralized monolithic configuration to reduce the organization's overall cost of transaction. But when we reduce the transaction cost, as information technologies and other innovations have done, then connectivity increases, interconnectivity increases, and the system can become unbundled from its centralized configuration, allowing for components to become distributed out and coordinated through networks. So this is what we're going to be talking about. There's 3 images down here. We're going to discuss each aspect here, this decentralized thing, aspect to complex systems and how we're going to design for that. Modularity is a key feature of all complex systems. They're too complex to be able to be bounded within one kind of centralized configuration. Again, the internet is a good example of that. It's not made by Microsoft or one organization. It's actually made by many different, and it has this kind of modular, they're all contributing their part in kind of a modular fashion. User-generated systems created by the people in it to a large extent, and services. We need to think in terms of services and service networks. Okay, so that's what we're looking at. Let's just take a look at the first one here around decentralization. Decentralized networks are without centralized nodes. Responsibility, control, and resources lie on the local level and are dispersed amongst a large percentage of the nodes. Examples of this include peer-to-peer file sharing, sustainable agricultural systems, car sharing services, and direct democracy. Decentralized networks typically require greater user engagement as they can't depend on centralized batch processing. The nodes in the network are often more self-sufficient and less specialized, and thus it's easier to interchange and replace any node with any other, making them less susceptible to attack and more robust to failure. So that's one well-known characteristic of decentralized networks. They're less critical and vulnerable to failure because they aren't dependent on those centralized nodes. And you see that, we know the internet is a very robust system. So many other kinds of complex systems. Decentralization can reduce inequalities, increase inclusivity, and harness the capacity of more people along more dimensions. They also have fewer dependencies and are typically more sustainable in the long run. However, decentralization creates increased complexity and decreased direct control. So this is what we're talking about at this stage. I'd like you to grab a sticky and try responding to my question here. Why do you think decentralization is important in the design of complex systems? Or can you give other examples of decentralization in design, being used in design? Or why might we use it? So for anyone who's not familiar, if you follow the link, John will be sharing with you in the chat, and then you just grab a sticky on the side here, you click on that icon, you put it down there, and then you can type in your response there on the sticky just by typing on your keyboard. Very simple, and that's all you do. We're gonna take maybe 5 minutes or so to leave you people post up your ideas on this, and then we'll come back and discuss them. Any questions? Happy to answer them. If you have anything as we go along, you could put it in the chat and maybe John will pick it up. We could try replying. Okay, is everybody able to make it to the Miro board and find what we're doing here? Okay, for those newcomers, I'll just share the link to the Miro board. You can see we're working on. We're talking about decentralized systems and decentralized networks. And the question is, why do you think decentralization is important in the design of complex systems? Okay, I'm gonna take a look at some of these and discuss what we got so far. So complex systems do not have, please stay posting up your stickies if you still have ideas. So complex systems do not have singular separate interfaces, but multiple interweaving ones, which require multiple points of simultaneous coordination and interaction. Anybody want to speak on this?
That was me. It just came to me when I was, when you brought up the Miro board. It seems that we're constantly being required to keep multiple balls in the air at the same time. I mean, they're all different shapes and they're all different weights, and it can be really hard. And if you have more than one person helping you to do that, I think you can get a really good, it's a lot easier to handle type of thing. I mean, I don't think any one of us could handle the world without having other people there to assist us. So.
And I think it gets the idea that they're not necessarily one thing, are they? It's kind of, separate interfaces and multiple. It's like the internet. It's not really one thing, is it? No. It's like massive amount of different parallel modular thing. All these companies interested in their own thing. And it's even difficult to talk about it as one, isn't it?
Right. It also works at different levels. And I think one of the things we forget is that the world is basically working towards entropy. We're always fighting against entropy, disorder. And we're also always fighting against trauma. I mean, we think that trauma is something that's, at least in my mind, trauma is always there. And we need to consistently figure out ways to address trauma when we're working on our systems.
Okay, great. So easier to include many ideas in small teams. Okay, anybody want to talk on that? Kind of agile principles?
Yeah, I can do that, Joss. I think when you have large teams, it's very easy to bury good ideas because there's a lot of people communicating and talking, and if you don't capture them, in smaller teams, it's easier to manage and to build on ideas and so on. That's certainly my experience.
And the whole idea is kind of the relationship between monolithic systems and kind of modular systems. It's kind of what decentralization. It's easier to include many ideas in small teams. Yes, and it's easier to also kind of deal with things, isn't it? You can kind of modularize them into something that's of a scale that people can actually pick up and manage and deal with themselves instead of something more monolithic, which is maybe more demanding. Yeah, we can talk more about that. So one person or one team will not be able to make decisions in a complex system, nor can they have access to all information needed for decision making. So you're going to kind of, distributing out the information processing is going to be important, isn't it? That's what you see in complex systems. It's like all these agents, and they're making decisions kind of locally and then interacting locally. It's not all dependent on someone really understanding the whole and so forth. Does someone want to talk on this? Ron?
Oh, well, not exactly your question, but from what you were saying earlier, In the early 90s, my company introduced object-oriented programming and using Smalltalk to Ford Motor Company. We replaced a COBOL system where the teams were generally 50 people, and they would go for a year and then throw away everything they did, where we had teams of 3 and 4 people being able to deliver things in sometimes a few days.
Agile approaches.
Yeah.
Okay, so it's definitely that principle of, Agile is trying to, it's the idea of devolution too, that you're pushing things out to the level, to the lowest level where they're relevant, where people can make decisions. In the European Union, they have this idea of devolution. They're not going to try and make decisions centrally in Brussels for everything. They're going to push it out to the kind of the lowest. It's kind of agile too, like let those teams make their own decisions and decentralize things in that way. Okay, easier to manage. Is it easier to manage? Who is this? I would question that.
It's almost impossible to manage that decentralized system.
Yeah, well, that's debatable, because it depends what you mean by management. You've actually got to go back and revisit your conception of management. If you stay in the same paradigm of management as, part of the traditional paradigm of management is that we've got to control the thing if we're going to manage it. So if you stay in that paradigm, we've got to have control. Without that, we can't manage. Then management doesn't make sense. But if you revisit that idea of management and update it a bit, then potentially it can still have, because you can still have influence, can't you? Who is speaking there?
Hi, it's Yuri, but you have no idea what you can get in return. From your point of view, you may have a decreased performance of a system as a result of decentralization, regardless of how you define management.
Yeah. But you still get to influence the system in some way, even if you can't kind of directly control and manage it, wouldn't you say?
Yes, you can influence, but there is no assurance that you would lead this system in the direction you wanted
to go. Well, that's kind of a key principle in complex systems. There's no real, because you give up the whole linear causation, the idea if I do this, then I'll get that. That kind of breaks down in complex systems. You can't say, I'm going to do this and the systems, I'm going to get that result out of the system that I want, which is a lot of what traditional management and design is actually based upon, that idea of linear control. That's not to say that you can't guide and influence the system in certain directions. So let's stay going, because it's a big debate there. We want to cover other stuff. Increased autonomy of systems components, for sure. Who's this? Someone want to speak on that?
Yeah, that was me. I think some of the points were already mentioned about easier to make decisions. So when the autonomy, especially in human systems, are increased, the motivation levels or creative ideas also increase.
Yeah,
with the autonomy.
It's kind of agile again, isn't it? That yeah, I mean, when we centralize things, we kind of take control away. We take adaptive capacity away from people, don't we? We constrain the components, but when we decentralize, we increase the autonomy and increase their adaptive capacity, and then their capacity to innovate and make their own decisions.
Right.
But then the challenge kind of goes back to this then. How do you actually get coordination if those actors, people, whatever they are, modules are making their own decisions and innovating? How do you then get coordination within the broader system is part of the challenge that these complex systems do manage to solve through kind of peer interactions. Okay, it prevents monopolies or other forms of individual actor power dynamics. Yep. Decentralization provides resilience. It is a key, yeah, someone want to talk on this? Decentralization provides resilience. It's a key ingredient to stability. Yeah, it's well known to provide resilience. You know, monolithic systems can become very brittle. It's often this kind of fixed long-term planning approach that can kind of fail catastrophically, these monolithic systems, whereas a resilient, decentralized one, if you have diversity in the system, also that really prevents it from those kind of catastrophic failures. Some parts may break, may fail. You know, the internet is a good example of that, right? Websites are getting hacked all the time, but the internet lives on, and it's a very resilient system because no one really controls it, and it's distributed out, right? Less prone to systems-wide failure. Yeah, easier to make changes. Is it? It depends what the change. Easier to make changes to the components. Is it, who's this? I'd say it's easier to make changes to the parts because you can kind of swap them out, right? But it's maybe not so easy to make changes to the whole thing if all these parts have their own autonomy and are kind of doing their own thing to a certain extent. It's not so easy to maybe change the whole. Easier to identify and manage interactions. Okay, decentralized systems are less vulnerable to the competence of person thing at the top. Yeah. Allow for emergence. Anybody want to speak on that?
Yeah, I think that was my note. And Joss kind of, I had another note speaking to what you were saying about developing greater resilience and avoiding kind of the aspect of being brittle. And so when you actually, this was one of my other notes, decentralization allows for greater resilience because there can be this ongoing adaptive cycle at different parts of the components, I think. So you can have almost this death and renewal cycle within different components. So overall as a system, you're developing this greater resilience. So, and I think that connects to this emergence.
Yeah, and I think it goes to the idea of resistance versus resilience, and kind of centralized systems. They try to have the kind of force and capacity to quite often resist change. They're very kind of, they quite often don't have a dynamic built in them for change, whereas decentralized systems, they can potentially have an evolutionary, like ecosystems, right? They're kind of decentralized systems and they have an evolutionary dynamic built into them. Parts obviously die and new parts come along. And as you say, the whole system can be adapting but kind of asynchronously. It's not all one big change. It's like different parts across it adapting to different changes, and we see how evolution works. Over time it manages to really kind of make big changes, but those are through kind of individual adaptations.
Yeah, exactly. I don't want to jump too far ahead, but it's the note beside it, which is also getting exactly what you're saying, that avoiding this Alice in Wonderland effect. And I forgot the author's name, Tainter, I think, who wrote The Collapse of Complex Societies, right? So he talks about essentially exactly what you're saying, this running faster and faster and faster just to stay in the same place because we're trying to control and maintain so much complexity versus allowing for this kind of emergence and resilience to emerge. And
you can also get a real big disconnect, right? But between, because the intelligence is normally centralized, isn't it? So it gets more and more removed as it grows from the actual interactions at the front line. So you can get this kind of, these people living in a very make-believe world that aren't kind of affected by the actual environment because they're protected from it. So you get these kind of ridiculous, I mean, you see it in dictators or whatever, they become totally disconnected from the world because they're just kind of living in a paradigm without actually having to interact with kind of the real world in the way that these decentralized systems, they don't have that kind of centralized component, like making those decisions. It's the agents actually interacting kind of on the front lines and adapting to what they experience. Okay, so to avoid systems breakdown, we all have our pieces of truth, and the combination of which gives the complete picture. Yep, so that's really the challenge, isn't it? Like then how do you, if you're decentralizing everything and agents are able to make their own decisions and innovate and adapt locally, again, the challenge becomes coordination between them and alignment and so forth. Okay, so might worsen the challenge of surfacing implicit knowledge, might result in less functional understanding of the system, thus disengagement. Yeah, might result in incapacity to know the whole system. Like that's what people often say about complex systems. No one can really know or understand the whole thing. So when you decentralize it, it becomes a lot more complex and agents are making their own decisions and no one entity can actually understand or control or coordinate the whole thing. So there's a loss of control. There's a loss of kind of full view of the whole thing. Okay. So that's that. What do we have here? To make it easier for decision making, reduces bias, allows for better ideas, insight generation. Yeah, outcome of decisions nearer to context. Okay, reduce dependency on communications infrastructure, which is critical in abnormal times. Yep. Okay, all done, guys. Let's stay moving for the sake of time. So here we're going to talk about modularity. It's obviously another aspect of this. You know, in Agile, you create these little teams, and that's kind of a module where they have their own kind of a degree of autonomy and so forth. But in the design of all these complex systems, you have this kind of modularity, an encapsulation of the parts within broader networks. So design for modularity. When designing a system, one of our key architectural considerations will be decide whether we're building a homogeneous system or a modular system. Modular design is a design pattern that is built around the idea of autonomous modules that can be independently created, easily configured, and reconfigured into different systems. So Lego is a good example. You make a Lego house out of all these modules, and it's not just one plastic injection molded house, which is one thing. You can then decompose it and recompose it again into different things and so forth. Okay, so examples of this might include an electric circuit board made out of autonomous electric units, or a house made out of prefabricated modules that plug together. Modularity is a key feature of complex engineered systems, with the internet being a paradigm of modular architecture, and many software systems are also designed in this way. We talked about object-oriented architecture, right? That was part of and service-oriented architecture. Over the past 70 years, we've developed more and more complex software systems and information systems that become more and more modular. And there used to be these big homogeneous, you know, scripts of code, which were kind of impossible to do anything with. And now they're these kind of microservice, pretty small snippets of code and modules, and they combine together in different ways. So the advantage of modular design includes they can enable distributed collaboration and problem solving. Modules can be endlessly reused like Lego bricks. We can combine and recombine them, making it more likely to be circular, sustainable solutions. Modular systems are more versatile, adaptive, and can be customized more readily. Modular design can be a very important contagion mechanism that should also be much easier to manage over the maintenance of the life cycle of the system, as components can be easily swapped in and out. So it's potentially a way of preventing contagion spreading by having little buffers, little modules that so things don't easily cascade through the whole system. Like a crack, right? If we had a house that was all injection molded with plastic, and it gets a shock in one place, the crack's going to ripple across the whole, very easily across the whole house. If it was made of Lego modules, it's probably just going to stay in that one module. And then you could swap that one module out and put in another one, and you've kind of solved it. So that's what we're talking about. And it's also a way of creating these kind of systems, user-generated systems, where people can make things, right? So if you give the child a plastic injected house, it can't really do very much with it, the little model house. If you give it a bag of Lego, it can make the house, but then it can make something else with that, and it can make something else again. So it can actually, it's a way of engaging the end user and giving them the capacity to actually do things with a system instead of it being a big monolithic system. Okay, so here's a question for you. Why do you think modularity is an important principle in systems design? Do you have any good examples aside from Lego of the use of modular design? Let's take 5 minutes or so to post up some ideas on that. Okay, for the sake of time, I'm just going to reply to some questions in the chat here, some good ones. Please stay posting up if you have ideas. So Claudia is asking, seems like a good inquiry is when to use decentralized versus centralized systems, operations, and how the whole system works together. What is the optimal balance? Centralization does not have to have many levels of control. So it's a good question, isn't it? Like, what's the ratio? When should we use centralization versus decentralization? And it's probably one of the first things you should consider. And it's also relative to the environment that you're operating in, right? As the environment becomes more complex and what you're doing becomes more complex, you have to decentralize things. But it's always relative, to the problem you're trying to solve and the system you're trying to build. How complex is it? Another one, is modularity a form of reductionism? Right, good question. In some sense, the opposite is systems thinking. In my experience, if we think about pricing of some service, the total price is often not the sum of the price of the module. So modularity, it is a form of reductionism, but if you think systems thinking is going to lead us to kind of a whole, in a sense, to a kind of very homogeneous system. So this is more of kind of a complexity principle which is about kind of integration and differentiation. You have all these little modules, but then how do you integrate them in the right way through networks? So I'd say it's more kind of complexity thinking. We have all these little parts, and how are you going to integrate them and get them working together within networks? But ultimately, system thinking is an argument for both looking at the whole and the parts. It's not just about the whole all the time, or else you would end up in a kind of very homogeneous design if you're just designing for the whole. Okay, so let's look at some of what you're talking about here. Writing code is increasingly moving towards a modular approach. Yeah, and if you actually, those platforms and the development of those information systems, these Google and Facebook and so forth, they're building very complex systems, and they're kind of at the forefront of systems design. If you look at what they've done over the past 10, 20 years, they've become increasingly modular and granular, going from service design, from object-oriented design, service design, and microservices now, where they just build small bits of functionality and code that communicate with others in a kind of a network. So that's a very good example, I think, of having to change your design pattern as the systems you're building become increasingly complex and do increasing modularization. It's very interesting to look at service-oriented architecture and microservices as a way of designing complex systems that those technology companies have adopted. Wondering about potential relationship between modularity and platform design as proposed by boundaryless, the former being descriptive and instructive, the latter being the rate-dependent manifestation of the former. So wondering about the relationship between modularity and platform. Someone want to speak on this?
Yeah, that was me again. This session is bringing up more questions and inquiries than it is bringing up answers. And this is something I've been thinking about for a while, but what we're doing here basically is rate independent, okay? We don't have to worry about how fast it goes. We could take an hour, we could take a day doing all this. But once you get into the real world, it's rate dependent. You have to get it done within a certain amount of time. Your flows and other things to have a specific manifestation in the real world, okay? And I'm just wondering about how these two things might work together, because I see a lot of potential here.
Modularity and platforms, those two things?
Well, because platforms oftentimes work on a modularity idea. Right.
So it's like I said, it's a way of engaging end users. Platforms create modules that me and you then go and plug into, right? So Airbnb has a template for someone to provide a room, right? A service provider. And then me and you come along, we log into that server, it dishes out that form, we fill in that form, and off we go. And that's a kind of a not modular design pattern.
Right, but then we can break the modulars between you and me down and further and figure out which ones has greater potential, which ones has greater value, concentrate on those, and then offload the other ones to some place else, like maybe algorithms or something. So there's a lot of creativity that we could put in here.
For sure. Okay, so modularity allows for greater responsiveness to disruption, important for resilience. Yep. So maybe able for starting for something easier, higher accessibility. Okay, individual agency has easier media to show and communicate. Possibility to creative share, chance to innovate. Yes, it allows for greater capacity for the agents to adapt and make innovations. So support reusability, yes. Modularity ensures failure occurs, it can be replaced easily. Yep. So what do we have down here? Modularity and decentralization is in a way, are strongly correlated concepts, for sure. Modularity, decentralization provides oversight despite increased complexity. Anybody want to talk on this?
Yeah, that was from my side. I think in a way, if you can make something very complex, like the Facebook example. I mean, God knows how many users are on there, but it's rather simplistic to understand it, right? Like once you get to know one template, then the rest is sort of just a repetition. So you're not really increasing the understanding complexity, but you are increasing the complexity of the overall Facebook. There's a very interesting correlation.
There's a lot of complexity behind the scenes in there to make, and that's what we see increasingly, like these services, these apps that are able to take something very complex on the back end and then have an interface that's very simple on the front end. Yeah, so modularity provides, what do you mean by oversight? What do you mean by oversight?
Maybe oversight is the wrong word. Like an overview, like a insight.
Yeah,
insight might be the right word. Like it allows you to still understand it quite fast.
Yeah.
Without actually like understanding the whole size of it. Like if you understand a template of a user on Facebook, you probably understand all of them.
And it's a way of creating complexity too, because like how Facebook works and how that design pattern works, they create a generic template of a user, and that's all they create, right? And then me and you, the user generate, me and you and 2.5 billion other people come along and we input our profiles and we connect with people and we interact and we post stuff, and that's where all the complexity explodes, isn't it? So I'd imagine how, if you look at it on that level, it's incredibly complex, but underneath that is this very simple template of a user, name, address, connections, so on and so forth. And then all the complexity, Facebook doesn't create all the complexity, does it? The complexity emerges. So that's a good example of platform. Obviously, Facebook's a platform, and then users on top of that using modules to create a lot of complexity, both in filling out their profile, but in the number of interactions, right? They're creating these big networks, right, of incredible complexity, social networks through their interactions. So it's a good example of actually emergence using the platform design and kind of modularity as a way, templates and modularity as a way of doing that. So in software systems, modular design allows reusability and enables faster innovation in individual components. Anybody want to talk on that?
Yeah, so I was just referring to the microservice design, as in I come from a networking background. So normally when we have modular designs, like for instance, in the system that I was building, we usually have different modules for components, like let's take GitHub, or let's say some TensorFlow, for example, where you have reusable individual modules like a sequential model or a deep neural network model. So these are components where you can independently innovate without being, bogged down by the entire system in general. And it also allows you to reuse the components or modules.
Yeah, so it's almost like you have a little bucket of primitive kind of components, don't you? Like there might be user input, some kind of data here, just as a random example. But then, as you say, that could be used in many different operations or different processes across the whole system. So underneath it is a bucket of different modules, and then you're putting them together.
Sort of becomes more of a platform design, I guess.
Yeah, it is. We're kind of getting at where platform design intersects with systems design here, I think. So, okay, let's take a look at a couple more. So collective can raise money and track finances without being incorporated. Okay, reconfiguration is possible as in car design. modular assembly can have many outcomes to satisfy multiple stakeholders, keeping costs to a minimal. So it's going back to this thing, there can be an underlining, and that's one of the principles of complex systems, that actually underneath complexity can be a quite simple set of rules generating that complexity. We used to think that everything that looks very complicated and complex had to be the product of a complicated set of rules. You know, like our legal systems, they're a product of a very complicated set of rules. But that's not how we get ant colonies, the complexity of kind of an ant colony. Actually, ants are very simple. It's the interactions between them, simple interactions that create the complexity. And that you can see that principle here again, as we talk about in Facebook, or in this kind of platform design. We have these modules, these primitive basic modules, and then we're gonna, on that level, it's very simple, and they can be plugged together in a number of different ways. But once you start to plug them together, you can start to build out a lot of kind of complexity, whether I guess that's internal to the system, the developers or the end users. It's how we kind of create all that complexity, and maybe underneath that is these quite basic building blocks. Okay, maybe, okay, so I think we've covered most things. Let's try and jump into one more board before we wrap up. This one here, thinking about end users. As we've talked about already, all these things kind of fit together quite nicely. As decentralization, you're kind of empowering people and you're giving them little modules for them to be able to do their own thing, and get that user engagement as a way to kind of create all this complexity that's needed. At all stages in the formation of our design, we should be thinking about user engagement and how to engage end users to be productive in creating their own solutions. Design should be about empowering people, not constraining them. With the advent of digital technologies, we have the possibility to really empower and engage people in the creation of the world they want to live in, rather than imposing our solutions on them. This requires first thinking, how do we push productive capacity outwards the end user? Using the means of production, putting the means of production in their hands, and then building a network to enable the coordination of production and exchange between peers. This may be a digital media platform for producing and exchanging media, transport with car sharing, or manufacturing and distributed fabrication. Okay, so we're talking about how to engage the end user here. How to use this kind of design approach, as we've talked about, decentralization, modularization, platforms, to engage and empower the end user. Let's take a couple of minutes just to post up any ideas or examples. I've had some good examples of this. That'd be good. Okay, let's take a few minutes. Okay, just a few minutes left, so let's take a look at what we have here. So incentive structures, but then the question is who and how, centralized, decentralized. Are these designed? Examples, cryptocurrency. Anybody want to talk about that?
Hi, can you hear me?
Yep.
Yeah, so I'm Jonathan. Yeah, I thought I was just thinking about how we can get people, if I understand the topic correctly, it's about how do we get people engaged in creating and participating in the creation of some system, if I've understood the topic correctly. Yep. And therefore I was just saying, oh, well, incentives are important. And then I thought I had a funny thought about, okay, well, who designs the incentive structures? And then I thought, well, it's actually, there's an interesting example, which is quite current, which is cryptocurrencies, where you generally have a central team of a few people who design a set of incentives. You could see it that way, an incentive structure, or at least a set of rules. And then you have a decentralized system, but it's actually where it's been designed by a set of very centralized group of people, even though the resulting system is decentralized.
Yeah, so I think it's a very good connection you've made. And maybe it's getting back to the platform idea. You know, a platform does have that centralizing aspect to it, doesn't it? As well as a decentralized layer, there's also that underlying centralized layer of the people who actually designed this. So it seems to be still there in the cryptocurrency world. But it's a very good idea, and it goes back to that question of how do we get coordination if all these people are doing their own things and there's no centralized control and no one really understands the whole and the whole thing, and we don't have that kind of linear control. How do we organize the whole thing? How do we influence it? Well, this is one way of doing that, isn't it? Incentives. And I think as you talked about in cryptocurrencies, well, they're starting to get into what they call mechanism design and game theory, which is about designing the structure of incentives in the system. So in that case, they're kind of a platform, and then they run that system, and the people in it do what they want to do. They go and follow their incentives, and they see what happens. So it's an example of emergence, and it's an example of influencing a system without direct control, right? They're not telling everyone what to do, but they're creating an infrastructure of incentives, which is going to guide the system in some way. So I think it ties in very well with the question of how do we get coordination in these complex systems? Well, through incentives, I think, well-designed incentives, and that's kind of the world we're going into, really. We know those decentralized systems, the blockchains and tokens and so forth are going to be very important. So what do we have here? In what way can we design to engage the user? Okay, do you have examples? Digitizing. Digitizing has helped banks and airlines to get the users to carry out the transactions on their own. Yeah, and not just them, in healthcare, in insurance, in many other areas. It's actually, we're getting more involved in the creation of the product through those forms that we all have to fill out. Okay, what do we have down here? Yeah, I like this one. Using Miro board is a good example of user engagement to organically enable or bring out the diverse heterogeneous insights like we're doing at the moment. We've created a certain structure here. It's a platform, right? And obviously it was designed centrally. I designed this, and then you guys came along and we got this user generated system and all this kind of complexity coming out of it. So I think that's a very good example, and maybe a good place for us to wrap up. I think we covered some really interesting and important topics there in design of complex systems, particularly around decentralization, modularity, end user engagement. I think these are really important, actually, and platforms as kind of one way of doing that, and central incentives too, we touched upon there. So great conversation, guys. Let's wrap up here. In the future, we've now finished our section on design principles, and in the future we'll be digging more into kind of methods and tools and so forth. And our little design team will regroup to think about how we progress there. But hopefully we'll get a chance to look at some of these toolkits and so forth that are used in systems design, have a discussion on that. But for the moment, we wrap up. I'll see you again, hopefully in a month or so. Thank you all for joining.
Thanks, Joss. Great event again. Thank you.